Hi guys, my name is Artur and today I would like to show you how you can deploy smart contract and then read or write information to that smart contract from React.js applications. Of course, I will use React.js just as an example. You can do that in any framework or library that you like. You can use jQuery, Vue.js, Angular, or any others. The React.js part is actually super small in this application. So first of all, we're gonna deploy the smart contract, and for that I will use ERC20, which is a standard of the smart contract that lets you build your own coin. So we'll build a dev coin, and then we're gonna mint some supply of this coin at the beginning, just to build some very simple application that we can use from our browser. So we can just type the contract address, because obviously if we are creating our own token, we have to deploy our smart contract. We're gonna use today a test network for that, so we will not need to spend any real Ether or real cryptocurrency. So once we deploy the contract, then we have the contract address that we can use in our application, and we can, for instance, get some information about our coin, about our token. Then of course we can also fetch the balance of the currently logged in user into the MetaMask, and then finally we can also try to send some money to some other address. So first of all, I will deploy our smart contract, which is the DevCoin ERC20. And if you are not familiar with how to deploy smart contracts, or what the import does, what is the constructor, how this basic syntax of the Solidity works, I highly recommend you to check Solidity docs and go back to some of my previous videos that you can find on my channel. So I think I can deploy the smart contract. So I'm using the injected Web3 environment, which is, in my situation, it's just an Rinkeby test network. So always be sure that before you do any experiments, you are using actually the test network. So we have the Rinkeby test network, and right now if I click deploy, it will ask me to pay some gas for the transaction. And of course, I'm using here not real money, it's just a test network. So I'm using my test money to deploy the DevCoin smart contract, because we need to have the smart contract address, because we want to use that address inside the React.js application. So right now you can see that here is our contract, and it's actually deployed, and we are able to copy the address of the smart contract, go to the Etherscan, just paste here the address of our smart contract, and you will see that it's just deployed. So this is our smart contract, and if we go here, we have the orange functions, which are write functions, that whenever we want to call them, we have to spend some gas on the transaction. So for instance, if I want to transfer the money to somebody, I have to use my gas. However, if we have these functions here, these functions are free of charge. You don't have to spend any gas. So for instance, if I call the name function, you see that we have the name of our coin, which is the dev coin, and here we have also the symbol and the total supply of our cryptocurrency, because the total supply was actually used here with the mint function. So let's see what is the balance of my account. So for instance, if I just paste here my account, then you can see that I have the total supply, because I'm the person who deployed the smart contract. And now I think it would be interesting to actually move this functionality that we have here in the Remix IDE to the React.js application. So we can just use the smart contract, as you can see here in the Etherscan and just use that smart contract address and start calling functions, because that's super useful, because people are not building the smart contracts to use them out of the Remix IDE or straight from the Etherscan. It's way more interesting to build your very own application. And here I will prepare for you sample application. You can find the code of this React.js application in the description to this video, and I will also put the small code snippet with this code for the Remix IDE. So before we start to talking to the smart contract, we need to install Ethers. Ethers is a special library that lets us communicate with the Ethereum blockchain. So we are able to issue transactions, we are able to create new wallets, we are able to use some smart contracts. However, before we can use the smart contract, because here I have just regular code of the React.js, and here we have some input where we can type the contract address. But when we click the get token info, nothing happens, because the handle submit just do nothing. But I will add the implementation right now. However, before I do it, I have to tell you one thing that is necessary, because before you can talk to the smart contract, you need to have two things. You have to have the contract address, and then you need to have ABI code. And ABI code is basically some kind of the schema of the smart contract. So we need this code, which is a JSON. You will see in a minute. I'm just clicking here, copy, and you can do it once your smart contract is compiled. So if I copy the ABI code, now I will add it to my project. I will just create a new file. I will call it ERC20 ABI, and I will call it JSON, and I will move it to the SRC folder. And actually, if I go to this file, you can see that we have some kind of the schema of our smart contract. And this is super important, because if we are starting to code in the JavaScript and interacting with the smart contract, our code need to know, okay, what kind of variables the smart contract offers, what kind of functions we can call. For instance, here we have the description of the event, because every time you are issuing the transfer, the smart contract emits the event. And this ABI code represents all the events, all the functions, all the public variables that smart contract expose. And of course, if you have here the NFT smart contract, or you just write here some functions on your own, then the ABI code differs. So it's not like you are able to generate ABI code for any smart contract on the world. You rather have to compile the smart contract and then generate the ABI code and then include it to your project. So we have here ERC20 ABI JSON, and now I think I'm ready. Import that file from, we'll just rename it, and now we can take care of handle submit function, so we can actually try to interact with the smart contract. So let's see what we have here. So first of all, of course, we need to take the data from our form. So here we can type some address and we need to take it. So we have the handle submit function that is called after clicking on this button. And here we have also to get access to the provider. So the provider we can get out of the window.ethereum. So whenever somebody has the MetaMask installed, then we have this object here, and we have to pass it to the new Ethers object. But of course, the provider is not enough because we also need to create a new instance of the smart contract using ethers.js. And here we are passing 3 parameters. The first parameter is the address of the smart contract that we want to talk. The second parameter is the ERC20 ABI, because we want to use the ABI of the ERC20 smart contract. Of course, if you have different smart contract, you have to generate the ABI code and just paste it to your project. Sometimes people are hard coding this inside the same file, but I always prefer to just name the file with the smart contract that I'm using. So in this example, it's ERC20, and I'm just saving it as a JSON. So we have, and then the last variable that we have to pass to the contract function is the provider. And here is the important thing. We are taking the provider that is exposed from the window.ethereum. However, this is enough if you just want to read from the contract. Then you can just provide the provider and that's it. However, it's not enough if you want to send some transactions. If you want to make a transfer, the provider is not enough. And I will show you in the minute how to interact with the contract also if you want to write some data. But then we can just call some functions. So here, for instance, inside the Remix IDE, you can see that we have these functions like name or symbol or total supply. And if we create the new instance of the ERC20 smart contract, then you see that we can call the functions, which is actually asynchronous functions that are returning the promise. We are awaiting this promise and we are just assigning the token name, the token symbol, and the total supply. So we have this. And I will just store this information inside the regular use state from the React.js. So we have some initial data like address, token name, symbol, but now we are just mutating the state with the things that we are just fetched from the smart contract. So let's see if it actually works, because I just deployed the smart contract on this address. And if we pass this address here and just use the get token info, you can see that we have this information fetched from the blockchain. So we are connected here with the MetaMask, and MetaMask is exposing us the provider that the ethers.js can use combined with the address and the ERC20 of our smart contract. So this is quite interesting, but of course we need to do more. So maybe let's focus right now on the get my balance function. So this function is actually a bit more interesting, because here we want to also get the address of currently logged in user, because this is quite common that if we want to get the balance of the user or we want to issue some transactions, and we basically need to know who is using our application. So we not only take the provider like in the previous example, but we are also requesting access to the currently logged in user, and we can use that. We can call on the provider the get signer function, and this would be assigned to the signer variable, and then we can again call the signer.get address to get the signer address, and then we are able to check what is the balance of the caller. So right now I'm using the same account, so it's pretty obvious. However, let's just store it again inside our state, inside our local state of the React application. And for instance, if I will just refresh the application and just copy the address of the smart contract, let's see how it works. So this is the address. Here we have the information about the dev coin, and then we can also get the balance of our account. So you can see that we have the total supply assigned to this address. However, if I would change the address here, so if I would go to this guy, completely different address, and if I would just get my balance, right now you see that this guy doesn't have any balance, right? So the owner of the contract has the total supply, but other accounts, if we choose them here from the MetaMask, they don't have the balance. So right now I will show you how we can use our smart contract, which represents the dev coin, and how we can write information to the contract, because as I said to you some minutes ago, it's not super useful just to read from the smart contract, but it's super interesting how we can write to the contract and how we can interact with the contract. So I will right now go back to my account that I'm the owner, right? So I'm getting my balance and you can see that I'm the owner. And now let's implement the transfer. So Transfer functions is super easy. So it just takes the recipient address and the amount. So we can specify where we want to transfer the money and how much we want to transfer. So here you can see that I already prepared the form because I don't want to use your valuable time. So we'll again focus on the handle transfer function, and you can just get back to this example because you have the link to it in the description. And if you have some questions, you can always ping me on my Discord channel that you can also find the link in the description, or you can just ask in the comment section down below. So let's see the handle transfer function. So first of all, we are just preventing the default thing because we are submitting the form, and then we are just want to take the form data. So this is the form that contains the recipient address, the amount. I'm not doing the error catching. This is a homework for you that you can extend this code and add some error catching because I just don't want to waste too much time of it. So we have the provider. Again, we are taking the provider from the window.ethereum. Then we are sending some request that is requesting access to the currently logged in user, to currently logged in account. Of course, this is in the secure way, so our application is not getting whole access to all funds, or we are not able to, I don't know, sign some transactions without user agreement. It's just fetching information about currently used account. Then we are getting the signer because this time, obviously, we want to sign the transaction. We are not fetching just information from the smart contract. We want to issue the transaction. So this part is same. However, this time we are taking the address of the smart contract from our state, and then we want to just issue the transfer. So we are fetching the recipient and we are submitting their information about the amount. So let's save it. Let's get back to our application and let's try to move some money to this guy, this poor guy that just had the zero. So so I will maybe just copy it. I will refresh the application and let's start again. So we have the token info, we have the information about the balance, and here I want to just transfer some money. I will paste here the balance. Maybe I will take 2 zeros. I will put here 3, and then I will hit the transfer. And you can see that MetaMask actually detected that we are using the ERC20 smart contract, because that's super great that if you are using the ABI of the regular ERC20, this means that you are not only possible to manage the DEV coin with our application, but we are also able to use any other coins that are on the blockchain that are using ERC20. So this code can work for DAI, this code can work for some stable coins that are using ERC20, and that's super beautiful. So let's see what MetaMask asked us here. They detected that we want to send 30 DEV, because that's how the formatting works. This is in way, this is are some decimals of this amount. So it's in reality it's 30 DEV, because the DEV is the symbol of the DEV coin, and of course we need to cover our transaction here. And let's confirm it. Let's hit it, and here we have the pending transaction that actually we can see here on the contract address. So here you can see that we have the transfer function that was issued from our React.js application, and of course it affects our current balance. So if I would click here, get my balance, you can see that I no longer have the total supply. And of course, if I would change my account to the guy that just received that money, which is this guy, then we can basically hit get my balance, and you can see that this guy has some money. So no longer zero. So our right work, because we can see it on the Etherscan, and also our application reacts to this this particular thing. So that's super useful. However, the last thing that I want to show you in this application is that we are able not only reading from smart contract, not only writing to smart contract, but we are also able to listen to the events that are happening on the blockchain. And this is also super helpful because sometimes we want to show something inside our application. We want to react to some certain event that is emitted from the blockchain. And here, if we check the transfer function, you see that we have the emitting of the specific transfer event. So if we are transferring the money, then we have access to some information inside the event. So let's try to do it, and I will show you in the other function. So here, for instance, if we have our code, I will just prepare the use effect that would be executed every time we are changing the address of the smart contract. And for instance, if the smart contract address, it's not the default value, we just want to run this effect, then we will get access to the ERC20 using the same method that before, that we have the window.ethereum provider, and we have the address, we have the ABI and the provider, and then we can also write ERC20 on transfer. So whenever the transfer happens, we can console log that, but not also console log, and I will just move the information about the transactions to some state. So I have here the really simple state, which is array, and every time some event is emitted or detected by our application, we can push the transaction information that is cached here to our array. So of course you are able to listen to more than one event. You can also specify here some filters that you want to listen just to the events that are emitted by you or sent to you. You can all customize that. However, I will not cover that in this video. If you have some questions about events, just let me know in the comment section down below, and I will shoot another video for you where I will tell you more about the events and how you can use them in your application. So let's save and let's see how our application works right now. So of course I need to copy the address of that smart contract, and let's refresh our testing application, and here I will submit the address, then I will fetch the balance. I will change maybe the account to the previous one, so I'm the owner of the smart contract, and here I will send another money, so it would be maybe the different amount. And if I submit here the transfer, you would see that I'm again asked about passing some 14 dev, plus of course the transaction fee. And if I click here, then we have transaction in the back. Of course we can add here some spinner, because issuing transactions, sending them to the blockchain always takes time. It depends how much we wish to pay for the gas transaction. It also depends on how the network is loaded at the moment. So of course it may have it can take some minutes for our transaction to be actually mined. But here you can see that we have the recent transaction here. So we have the amount, we have the from, and we have to, and we have also linked to the Block Explorer. So the Block Explorer represents that somebody transferred the amount of the dev coin, right? So how cool is that? You can see that we have the transfers of our cryptocurrency, and we are able to detect this information inside our app. And of course, this is super great that of course, if we issued the transaction from completely different source. So let's go here and maybe let's just copy another address here. So I will just send money to some other guy, maybe this person. I will move to the owner of this smart contract, and here if we just submit the information and we will maybe send a different amount, then we can paste it here, submit maybe 7, and then we can send the transaction from different source. So right now I'm issuing the transaction not from the React application, but maybe some other application that talks to the blockchain, right? So we have this transaction pending. Here we still can see it pending here. Right now it's mined, and let's go to our React application, and bam, you can see that our application detected this event, even if it was detected from completely different source. And what is funny, here we also have this listener, because this Code Sandbox instance also contains the event listener here, and then it just works. So it's pretty nice. Of course, there is one thing that we still have to fix with this use effect, because we are not doing here any cleanup. So I will just create some instance of this ERC20. I will keep it in the state of the application, and whenever we are closing the application or unmounting this component, we want to remove all listeners, because we want to avoid situation that somebody changes the smart contract address and we still have some old listeners. And the last thing that I would like to show you is that you can use that code for any other ERC20 smart contracts. And that's the beauty of the decentralization, Web3, blockchain, and so on, that if we are supporting our smart contract, nothing stops us from actually using any other smart contracts. So let's go to the Etherscan.io, and here I can just specify DAI, and we can go to the DAI stablecoin, which is also ERC20, and we can just copy the address of this smart contract. Here I will just make sure that I'm on the Ethereum mainnet. So I'm on the Ethereum mainnet and on my address, and here I can specify the address of the DAI. And if I would here click here get token info, you can see that our React.js application works. We have the name of the DAI, we have the symbol, we have the total supply, and we have all the recent transactions. So we have the listeners that listens to all transactions that are emitted on the blockchain on the DAI stablecoin. We don't have to sign any papers. We don't have to ask anybody for permission. Just imagine if your regular currency could work that way. And of course, last thing, I would like to invite you to my email course. You can just leave your email and you will get from me some curated materials about Web3, smart contracts, Solidity, and more. Besides that, you will also get access to my Discord channel, on which you can ask questions or just say hi to other developers or share your project. That's all I have for you for today. So you learned how you can read from the smart contract, so you can call any function you want, and then you can also write to the contract and then listen to all the events and present them in the app. All the code is in the text in the description. If you have some questions, feel free to ask them down below. And that's it. Thank you for your attention, and see you on this channel.